This is the Secondary Math 2 Unit 7 review. We're going over Section 2. So 7.1 is special right triangles. 7.2 is when we actually get into the trigonometry and the trig ratios. So with the trig ratios, you have to remember that when you have a triangle, so I'm going to just draw a very generic triangle, and you have a right angle. When you're talking about a specific angle, so let's say I'm talking about this angle right here, it's common to use this symbol, it's theta, in relation to that angle, so the angle placement matters. We have the opposite side, the adjacent side, and the hypotenuse. So we need the opposite side is the one, that's the angle, this is the opposite side. It's not touching that angle at all. To this angle, this is the adjacent side, and to this angle, well, to all the angles actually, this is the hypotenuse. So when you're talking about trig functions, what you need to remember is SOHCAHTOA. With SOHCAHTOA, this is telling you that sine is going to be equal, sine of the angle is going to be equal to the opposite side over the hypotenuse. And cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. Okay? So when it's asking us tangent of angle A in this problem, where is angle A? Well, angle A is right here. So that's the angle that we're working with. And in relation to that angle, okay, so looking at that angle, this is the opposite side, this is the adjacent side, and this is the hypotenuse. Okay. So, if I say tangent of that angle, I know I need opposite over adjacent. Well, the opposite side is 3, and the adjacent side is 4. So, 3/4. I'll write that so you can actually see the 3. Cosine is adjacent over hypotenuse. So that's where we're going to go, okay, the adjacent is 4. And the hypotenuse we don't have yet. So it's a problem. So what we're going to do is use our knowledge about right triangles and say, oh, well, I know that when I have two sides on a right triangle, I can find the third side by using Pythagorean theorem. So we're going to say side squared plus the other side squared equals the hypotenuse squared. And I usually use m for my missing side. Remember, your hypotenuse has to be by itself. So when we work through this, we get 16 plus 9 equals a missing side squared, which is 25 is the missing side squared. And then to undo a squared, you have to do the square root. And then the square root of 25 is just 5. So that means that this side is 5. So when I have cosine of that angle, I'm going to take 4, which is the adjacent side, over the hypotenuse. And with sine, I'm going to take the opposite over the hypotenuse. And those are my answers for that. Now, as a side note, if I had asked for maybe sine of C instead. Then we'd be looking at a different angle. Use a different color. So if we were looking at this angle, this would be the opposite side, adjacent side, and hypotenuse still. So sine of this angle is 4/5. So where the angle is matters. Okay, so for this next one, it says find the exact value by drawing a right triangle. So we're going to do basically what we did here. So I'm going to draw a right triangle, and it's telling me tangent of theta. So I get to pick where theta is, because if I picked it to be in a different place, then the opposite and adjacent sides would flip. So in regards to that angle, if that's my angle, I know tangent is opposite, which is this side right here, over adjacent, which is this side right here. And then I don't have the hypotenuse, and I need the hypotenuse to be able to get sine of it, because sine of that angle is going to be opposite over hypotenuse, and I don't have the hypotenuse. I do have the opposite side. So what we're going to do is Pythagorean theorem again. So I'm going to say 5 squared plus 12 squared equals the hypotenuse squared. And then we have 25 plus, I'm losing my markers, 25 plus 144 equals missing side squared. So then 169 equals missing side squared. Take the square root of both of those and you get 13. So if we took the square root of both. So that means that the hypotenuse is 13. So sine of the angle is opposite over hypotenuse, or 5/13. And then that's your answer. Okay, if we keep going down, we have cosine of 30 degrees, sine of 45 degrees. We can actually find those exact values using our special right triangles. So if I have a 30, 60, 90, remember whatever this side is, this is that times the square root of 3, and this is 2 times that value. And with 45, 45, those two are the same, and this is just times the square root of 2. So we're going to apply our trigonometry to our special right triangles. So if I say cosine of 30 degrees, I'm looking at the 30-degree angle. Now in relation to that angle, this is the opposite side. This is the adjacent side. And this is the hypotenuse. It doesn't matter that I have these unknown variables right here, the a's. Because what I do know is that cosine is adjacent. So a square roots of 3 divided by hypotenuse. Well, I know that if I have a divided by a, that reduces to 1. So I really just have 1 times the square root of 3 divided by 2 times 1. So the variables reduce away. Okay, now if I'm looking at sine of 45 degrees, I'm going to look at a 45-degree angle. Now, it doesn't matter which one I look at. You could look at the one down here, up here, because the 45-degree angle, it's going to give you the same answer. So in relation to that angle right there, that's the adjacent side, that's the hypotenuse, and this is the opposite side. So sine is opposite over hypotenuse. And again, the a's can reduce. So I have 1 over the square root of 2. We don't like having radicals in the denominator, so we're going to rationalize it, similar to what we did on the last video. And I'm going to say I'm going to multiply by 1 in the form of square root 2 over the square root of 2. And then when I multiply that straight across, I get 1 times the square root of 2. And square root of 2 times the square root of 2, which is 2. Okay, and these last ones, I get to use the calculator. Make sure you can see that. So when it says tangent of 38 degrees, all you're doing is typing in tangent 38. The one thing you need to make sure of is that if you hit mode, on the graphing calculators, this is how they're going to look. Every calculator has it, even the ones on your phone. You want to check to see if it's in radians or degrees. We want degrees. So then tangent of 38, and it doesn't say where to round to, so I'm just going to stick with, we'll do the hundredths place. So if this is 0.781285 stuff, the hundredths place, remember this is the tens, so this is the hundredths, this is less than 5, so my answer is 0.78. So then sine of 71, so again, if that is 94518 stuff, when I round this to the hundredths, tenths, hundredths, so the 4, I look over here, 5 is bigger than or equal to 5, so I have to round up. Okay, these next two are a little bit different because I have to use what we say inverse tangent. And inverse cosine. Okay, so when I do this, it's usually going to be the second button and then your sine, cosine, or tangent. You see how it's like blue? So we'll do second tangent and then 0.1944. And I'm just going to round this one to the nearest degree. And then this one, put the calculator over here. So again, second, and then cosine. That gives me my inverse cosine, and 0.2969. So if I'm rounding to the nearest degree, then it's just 73, because the 7 is bigger than 5. Okay. And that is all I'm going to do for this video.